The reason they're called exponential functions, where is the variable? It's the exponent. That's why they're called exponential functions. So, to graph these, that's all we're doing today. I know that's one of your favorite things, isn't it? Now you're going to have to make your own XY axis. Do not put the marks on it yet. Just draw the XY axis. You're only going to have to do, most of the time, 3 points. But we have to do enough points to sketch the graph. Sketching the graph means we're not doing it every point on the graph. We're not making it exact. We're going to graph a few and sketch it. Now this one, you have to do on every one of them. First thing we're going to do is put 0 in for x. Guys, we need to stop talking. Now that means we put 0 in for x here. We've got 5 times 1/2 to the 0 power. Let's see if this class is smarter than my other classes. We've already done this. What is anything to the 0 power? I knew it. 1. So now here's the other question. Let's see if you can pass this one. Write the final answer there. Don't say it out loud. Finish it. You got 5 times 1/2 to the 0 power. Write down what that equals. We just told you half the answer. So what is the answer? Ryan? 5. Why is it 5? Because 5 times 1 is 5. Amazing. And you wonder why we get frustrated. All right. Now let's graph that. This is our y-intercept. So we got 0, 5 in our table. So we're going to go up 1, 2, 3, 4, 5 and put a point. You're going to see in a minute here that every exponential function is a curve. Now basically what we're going to try are points on this side first. So I want to use 1 for x because I want to try that one. So we're going to put 1 in for x. Let's see how many of you can figure that out now, putting 1 in for x. You've got to put 1 in for x and figure that out, get an answer. Evaluate. So what's that answer? No, it is not 5.5. How about 2.5? 2.5. Now, the only reason I'm allowing you to say 0.5 here is because 1/2 is an exact decimal and 0.5 is exact. You're not going to be able to change all these fractions, some of them to decimals. You'll have to work with them as fractions because we want exact answers. For example, 1/3 is 0.3 repeating, isn't it? So we can't change that. No rounding. Got to work with fractions. All right, so this answer was 5 times 1/2, which is 2.5. So that means I go right 1 and up 2.5. You're going to have to estimate, eyeball it, halfway between 2 and 3. Question, Ryan. Now I still need another one. Let's do 2. See if you can do that one. Put 2 in for x. All right. Now I'm going to do 5 times 1/2 to the second power. Of course, to the second power means to square, doesn't it? How many of you knew how to square 1/2? What is 1/2 squared? 1/4. All you do is square the numbers. What's 1 squared? 1. What's 2 squared? 2. So it's 1/4. Okay? 2 squared is 4. Now, what's 5 times 1/4 is the last. See if you know how to do that. No, it's not 5 1/4. It's 5/4 or 1 1/4. Let's show you how that's done because I know we need refresher. 5 over 1 times 1 over 4 is 5/4. Then you write that as a mixed number. 4 goes into 5 once with 1 left over, so it's 1 1/4. You might as well start practicing. Quit changing them to decimals because you're going to have to do some in fractions anyway. So now I go up 1 1/4, just up a little bit. We're estimating. Now that's all we really need for this curve. Now let me show you what it looks like. It starts up here. I'm going to start from down. Well, no, we'll start from up here. I just want to get a good curve. We can start from either direction, but here's what it's going to look like. It curves and it comes down and it approaches, but it never touches the y-axis. Or the x-axis, thank you. And you need arrows on each end. I don't mind if the arrow does because that's not part of the line. We're just the arrow saying it's continuing. It's kind of like this situation. If I was standing at this wall facing it and I said I have to go half of each segment. So if I go halfway, I would go here. Then if I cut it in half again and go another half, I could keep doing that. Would I ever touch the wall? No. If you're always taking a half of it, you're getting closer and closer but never touching it. It's kind of the same idea here. All right. So that's what a curve looks like. Now you're going to see 4 different types here. Let's do number 2. Again, the first one you always start with is 0 to get your y-intercept. And I never draw my lines on this yet. I like to see what I'm doing here first. So I have x comma y. I'm going to put 0 in. Let's see if you can do that one. Right? Put 0 in and figure out the answer. You can't really use I don't know why you're using calculators on this. You shouldn't be using calculators on this. In fact, I may just not let you on the quiz. You need to do these in fraction form. All right. I have 1/4 times 2 to the 0. So I got 1/4 times 1, which is 1/4. Then it is negative. I'm sorry, you're correct. Didn't see the negative. Put that in there. Thank you. Now, this is why I didn't draw my lines yet. I'm going to have to estimate 1/4, so I'm going to make my lines, my measurements or units wider here. So I got plenty of room. And you also need to make them the same width when you go on your x and y axis. Don't make these wide and then make these smaller. That I will count the whole thing wrong. Graphs should be segmented or use units that are the similest possible. Yes. But most graph paper, though, unless you relabel it, you know, the segments are pretty small. So you could relabel it, though. You know what I'm saying? And maybe use the lines as a 4th, like count 4. You know, does that make sense? That would be a good thing to do. be more accurate. All right, so I need to go at 0. I need to go down 1/4, so I'm going to go about 1/4 of the way. Got to kind of eyeball it, estimate it. This is why you all are support doing some of this stuff. You've never dealt with fractions and never been really practiced enough with them. Your elementary teachers, too many of them said change them to decimals, I bet. How many of you had a teacher that told you to change them to decimals? That's what I figured. They should be fired. And I'm not kidding. You should not be changing fractions to decimals. You should learn how to do fractions. Now, because I got people in pre-calculus. Think about this. They can't do pre-calculus because they can't do 5th grade math. Because they can't do fractions. So, you should really know how to do fractions. I don't want to discuss it. We're doing a problem right now. All right. The next thing we want to try is +1, which would be right here. Put 1 in there and let's see what you get. Shh. Put 1 in here and see what you get. If I put 1 in for x, you have -1/4 times 2 to the first. So what's that going to be? -1/2. Because this is the same as over 1, isn't it? You just multiply straight across. You'll get -2/4, which is reduced to 1/2, -1/2. So you can see here that we're not going this direction. We're not going up. As we go to the right, we're going down, aren't we? So I'll estimate about 1/2. Now I can see the direction of my graph, can't I? Still need one more. Let's do +2. I'm going to do this one over here. You got -1/4 times 2 to the second. -1, very good. Because you got 2 squared is 4, 4 times 1/4. If you have 4/4, that makes a 1, doesn't it? But it's negative. So that means when we go to 2, we'll go down to -1. Now I can see my curve. Now, do you know where it's approaching the axis but never going to touch it? Which part of that's going to be? It's going to be right here. Very good. -x. So here's what it'll look like. It's coming up this direction, going through these points, approaching this axis but never touching it. And it actually probably will hit a point. Usually exponential functions hit a point where they just start going faster and faster and faster down, like that. That's why they're called exponential functions. And they're curves. But they always hit a point where all of a sudden they just increase, 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 and go faster and faster. All right, let's do number... Wait a minute. Yeah, number 3, and then we're going to do 5. Let's do number 3. See if you can do number 3 on your own. Let's see if you can do the whole table and graph on your own. Again, you always start with 0 for your first point. Sometimes you're going to need to go to this side over here, use -1 and -2. I don't know if that happens on this one. I don't think it does. I know on number 5 that's where we're going to do it. We need to do it. We have to do that on number 5. But you're going to have to, on some of these, make your own decisions by the way the graph looks. See which side do I need to make sure I know which way the curve is going. So let's just check the first point. What do you get when you put 0 in? Yep. How many got 2? Because a 0 makes this a 1 here, doesn't it? So you have 3 to the 0 is 1, 2 times 1 is 2. So we know this graph's going to go through the y-axis at positive 2. What's the next point you tried? You mean tried 1 for x, right? If we put 1 in for x, yes. You'll have 2 times 3 to the first, which is 2 times 3. Now you notice, as we go to the right, what's the graph doing? And isn't it doing it really quick? It's going to go up quick. So right 1 up 6. And if you actually put 2 in here, 3 squared is what? Yeah, do you see how now it's really going to go up fast, isn't it? So you see what I'm talking about. Now, what do you think it's going to do on the other side? On the x-axis, at the negative x again, isn't it going to approach it but never hit it? You follow me? Okay. So let's do -1 just to show you. Let's get a point on this side, because I want to see if you know what to do with it. If I put -1 in, you got a negative exponent. So you're going to have 2 times 3 to the -1. I'm going to give you 2 bonus points if you know how to write that correctly. Figure that out. Don't say it out loud. And no, it does not make it negative. Negative exponents never make a number negative. It's not what it's about. What does a negative exponent tell you need to do with that number? You need to move it. If it's in the numerator, you need to move it to the denominator. If it's in the denominator and a negative exponent, you move it to the numerator and make it positive. When are we going to remember that? I hope. I've been talking about it for a month now. Some of you still want to put a negative on the number when you see a negative exponent. All right, so that basically means we have this, which really means now I need to take 2 over 1 times what? 1/3. And you get 2/3. So how many got 2/3? Give yourself 2 bonus points. So we go left 1, and you'll see how this is helping us see that the curve is going to go down here. Because if we go left 1 and up 2/3, that's right about there. Oh, that's a little high. I'd say right about there. It's kind of hard to estimate that. But you see that it's going to be less than this 1 line, right? 2/3. So now we see what it's going to do. It's going to come from way up here, like it was going up to 18, remember? Come down through here and curve and approach it, but never touch it. So can you see the trend of the line? We know on this side it's going up really fast. Then once it hits this turn, it starts approaching and flattens out, doesn't it? All right, we're only going to do one more. Let's see if you can do number 5 for bonus. How many got the 2 bonus points on this? Okay. Do number 5 for bonus and we'll be done with the examples. Oh yeah, I like this one. Fraction, fraction, fraction. And again, this do not turn these into decimals. Work with fractions. This is another one where I'd make my marks larger, wider apart, because you're going to have to do fractions. You should do some numbers on both sides of the y-axis, positive and negative x-axis. Let's just see if we're on the right track. What did you get for the 0 value of x? Yes, negative 1/3. Because it makes this 1, doesn't it? Negative 1/3 times 1 is negative 1/3. What did you find out when you, I know a lot of you did this, what did you find out when you put 1 in there? You get negative 1/6, don't you? So that tells you at 1 you're just barely going below the line, aren't you? So you see, you can tell where the exponential curve is going to approach the x-axis right underneath it, isn't it? But it's never going to touch it. So that means you need to try over here to get the other side of the curve. So if we put negative 1 in, oh, 2/3. Because what happens? Yes. Since it's a negative 1, it flips the 1/2. So you'll have negative 1/3 times 2 over 1, won't you? Doesn't make it negative, it just flips it. And that equals negative 2/3, doesn't it? So at negative 1, we're going to go down 2/3. And I'm going to make you do another one, because I want to see what you do with it. I want to make sure you know how to handle it. Let's see what you get for negative 2. So in case you need to do this, you'll know how. This time, you not only flip it, but what else you're going to have to do to the 1/2? That's going to be the same as negative 1/2 times 2 squared. 2 over 1, right? What happens when you flip this? What happens when you flip this? It's 2 over 1. And that makes it a positive exponent now. When you flip it, you're making it positive. Oh, this is, I'm sorry. Yes, thank you. So now you have negative 1/3 times 4 over 1, which is negative 4/3, which is negative 1 and 1/3, right? So at negative 2, we go down 1 and 1/3, which is right about there, and you can start seeing the line starting to curve down. So it's going to look something like this. As we sketch it, it approaches but never touches the x-axis. And if you keep going out, it goes down faster and faster. Pretty soon it looks like it's going straight down, but it's not. It's still curving. It's always curving. All right, that's all you need. You have 15 problems. 2 bonus points if you got that. You have 15 problems to do by Monday. That means you get this period, tomorrow period, and plenty of time, which means what happens on Monday. No, just do the next 2 pages. Yes.